large language models have been around for several years.
Yeah.
It's just that nobody outside the industry noticed it because the way of interacting with them was through an API.
Yeah.
That's the innovation that OpenAI did with ChatGPT. It wasn't the creation of the large language model that we know as ChatGPT.
Yeah.
The real innovation was the interface.
Yeah.
The fact that you could talk to it like an SMS type messaging service, right? That was the new thing. And suddenly everybody saw it and was like, wow.
Hi, friends, and welcome to this exciting episode of Leading with Data. Today, I have Patrick with me, who has joined us from San Francisco. Hi, Patrick. So, Patrick brings an immense experience working across different domains and is doing some very exciting work. And I'm hoping that by looking and sharing his journey, we all can learn a lot from it and then apply it to our own careers and our own challenges. So, welcome to the show, Patrick.
Thank you very much for having me. It's a pleasure to be here.
Sure. So, Patrick, let's start from start of your journey, and then when you started, was it analytics and data science you had in mind, and what were early days for you? And then, was there any aha moment or incident which led you to data science?
Yeah, it's a good question. So I'll start at the beginning. I think my father always had astronomy books lying around the house, and it has beautiful pictures of galaxies and stars in it. And as
Mm-hmm.
a kid, I was always interested in that. So ultimately, I decided to take a physics degree when I got to university to learn how the world works.
Okay.
And as you might imagine, physics is mostly about mathematics, figuring out equations and how various quantities interact. And then there's the laboratory part.
Mm-hmm.
I'm horrible in the laboratory, right? The
Okay.
the experiments never worked out.
Oh,
Things broke
God.
and got dirty and whatnot. It was a nightmare.
Mhm.
And this was, of course, back in the days before internet and things like that. So we would write down the results with pen
Mhm.
and paper in a notebook, and it was a mess.
Yeah.
So I definitely went through the theory route.
Mhm.
And as I was in the United Kingdom, I took my degree in London.
Mhm.
Culturally speaking, you do the research work in theoretical physics in the mathematics department.
Correct.
So, okay. After I finished my master's, I then went to the mathematics department to get my PhD.
Mhm.
And we worked on some physics projects that needed a lot of data analysis done.
Okay. Interesting.
Um, and then I ran across this thing called a neural network.
Wow. And what year was this?
This is in the late 1990s,
Okay. Interesting. So this was
right?
the first phase when neural networks were getting attention, but some people were also discarding it because of lower accuracies. Is that true?
No, this is already after that,
Okay. Interesting. Mm-hmm.
right? So the 1980s was the big wave.
Mm-hmm.
When neural networks were advertised everywhere, there were many startup companies.
Right.
There was a lot of hype, very comparable to today.
Yeah.
A lot of hype about this thing, neural networks, machine learning, that was all the rage.
Mm-hmm.
People from the community promised all these business people that this is going to solve all your problems right away and it's super smart and all that.
Yeah.
And of course, it failed.
Mm-hmm.
Um, and so in the 1990s was what we call the AI winter,
Mm-hmm. Yeah.
right? When there was no more funding, everybody said we tried out this thing, artificial intelligence.
But
It's just broken and it doesn't work. Um, so to this day, by the way, you get people telling you that we've tried it, it doesn't work.
mm-hmm.
We've tried it in like '89,
Yeah.
doesn't work.
Doesn't
So we're
work.
not going to try it anymore.
Correct.
Okay, 30 years have passed. Give it a shot.
Mhm.
But that was the atmosphere
Mhm.
in the 90s, that artificial intelligence is a failed technology.
Interesting. Mhm.
Um, But nonetheless, we had work to do, and there were certain limitations on resources. And so I figured, as part of my PhD thesis, we would make this attempt.
Hmm.
It worked out at the time. This is, of course, using computer resources that are significantly less than any of your mobile phones today, to do this. But nonetheless, it worked out.
Hmm.
So that's when I really got interested in kind of this unification of theoretical approaches and practical laboratory approaches, right? You could do mathematics driven data analysis using a computer, and get some actual insights.
Got it. Interesting. Hmm.
So I was always taught by my ecosystem, my professors at university, that really the only job worth having was a research professorship. Um, you know, Making money out in the industry, that's for grubby, greedy people who are,
Yeah,
sort of semi smart. But the good people, they stay at university.
the university. Yeah. Hmm.
So okay, fine. I got a job as a professor in Germany. I'm German
Okay.
from my origin.
Hmm.
So I got a job in Germany. I taught there for 3 years, did research, published some papers.
Hmm.
But I figured out, kind of late, that in order to apply the applied mathematics, you really need to exit the university.
Got it.
You need to be able to do things like hire people, write an offer letter, or collect money.
Yeah.
You can't do that at university. So I started a company.
Hmm.
I said, okay, let's bring this neural network ideas to the industry. And by industry, I searched around, and in Europe at that time, the petrochemicals industry was very big. It still is. And they said to me, look, we have two major problems.
Hmm.
The first is that equipment breaks down and we don't know.
Yeah.
Can you give us a forecast?
Hmm.
And the other thing is that there are all these set points that we have to do, basically, dials that you have to set,
Hmm.
and then certain things happen. Those dials are being set based on personal experience.
Got it.
Surely you can do better, right? So why don't you calculate
Hmm.
what I should set the dial to, so that the outcome is the best possible?
Interesting.
Okay. I spent the next 15 years doing those two things.
Wow. And these equipments were drilling equipments or pre-drilling or transportation. So what kind of equipments were you trying to predict the failure on?
This is like gas turbines, steam turbines,
Wow.
pumps, compressors,
Hmm.
mostly equipment that rotates.
Sure. Okay.
Um, and
Hmm.
then you have vibrations, and things like that that give you information about what's going on in there.
Hmm.
Uh, and they can break for the silliest reasons, right?
Got it.
Uh,
And it's
so
largely thermodynamics and then wind flows at play, or these could be mixed phenomena, and because that would ultimately determine what data would you capture, and then how would you start to attempt to solve those problems. Is that correct?
yeah, I mean, thermodynamics plays a role, but
Hmm.
it's largely mechanical, actually.
Okay, interesting.
Yeah. So it starts off with a very tiny mechanical defect.
Hmm.
And as the thing ages, the mechanical defect gets a little bigger and a little bigger, and ultimately it leads to a failure.
Got it.
Um, or it's other stuff. For example, with wind turbines,
Hmm.
the most popular problem is not enough lubrication,
Okay.
right?
Mhm.
So there's $100 lubrication pump in a wind turbine that, being cheap, it fails sometimes, and then there's not enough lubrication. As a result, your $10 million wind turbine will burn down,
And, wow.
right? So
Mhm.
monitoring that is important, and one thing leads to another.
Right. Interesting. So these problems which you were solving, what kind of tools and techniques were you using, and then how did the I guess there are multiple things happening, right? The computation is becoming cheaper. There are new methodologies coming. The rate at which you could capture data would also presumably be increasing. If you have to, let's say, double click on these 15 years, what did they look, and how did these tools and technologies evolve?
Yeah, they evolved a great deal. So, of course, sensors have been around since the sort of late 70s, early 80s. So, measuring things like temperatures, pressures, vibrations, that's been around. Um, so, since the sort of early 90s, we've been able to record those things in databases.
Hmm.
Um, so, by the time I got there, databases already existed of these measurements, right? So, I had a beautiful data set structured in columns and rows, very nice how a data scientist likes to have their stuff. Um, and we were able to run models on them right away, right? So that's a tremendous benefit that the petrochemical industry already had, which
Hmm.
other industries didn't, right?
Didn't at that time, yeah.
So in other industries like logistics and retail and so on, we've had to work quite hard these past few years to develop these databases.
Hmm.
Um, so then what we did is basically gathered a lot of domain knowledge
Hmm.
around these things to try to get the data scientist educated on the domain and the machine,
Hmm.
and get sort of the mechanical engineer educated on data science. And now these two people can have a conversation and exchange information. So, as you all know, one of the most important questions for things like neural networks is, what are the input variables,
Yeah. Hmm.
right? I can do a lot of good by choosing the right ones. If I include the wrong one, then I disturb the system, right? So that is a conversation between the domain expert and the data scientist,
Hmm.
sorting that out. Then, of course, I have to clean the data. So all these usual topics that we still talk about today, they were very much the forefront. And those two things, basically, choosing the right problem setup and cleaning the data, that's 80% of your work.
Hmm. Hmm. Interesting.
Yeah. And then, of course, you gain experience as you do this once or twice, and then we ended up with a whole fleet of things like compressors and turbines under management, that we looked at, and we eventually came up with a tool, an actual software program that dealt with it all, and it started being a service, but it ended up being a product.
Interesting. Interesting. And this tool which you deployed, was it like a simulation environment where people can test out these settings, etc.? Or this was, if you put in the details about these, for example, equipments, it would give you a heads up. I mean, what would these software do?
Yeah, the output is not a simulator, but
Mm.
an actual suggestion, right?
Okay. Mm-hmm.
So the system would tell you, please increase the temperature by 10 degrees. And
Mm-hmm.
if you do that, the result will be that your efficiency will go up by 2%,
Right.
right? So
Interesting.
it would make a very concrete request of
Mm-hmm.
you to do something, and would tell you what the result would be if you did
Got it.
that.
Mm-hmm.
It would then still be up to the human to say, yes, I'm going to do that,
Sure.
or,
Interesting.
or not, of course, right? Because the human always has some other information as well accessible that the computer simply doesn't have access to, right?
Correct. Correct.
So
Mm-hmm.
that phone call you just got, that something wrong happened somewhere, right? The computer doesn't know about that. So
Mm-hmm.
having a human in the loop is usually essential.
Correct, correct. And a lot of this work, was it like numerical based, data based calculations, or were these like the actual physical equations being fitted, and some sorts of regression trying to kind of achieve these relationships? So what kind of these underlying data models were you using during this period?
Yeah, so the underlying mathematics of it was really neural networks.
Oh,
So it started with things like perceptrons. It then
mhm.
became things like LSTMs,
Wow.
uh, sometimes convolutional neural networks. So these techniques were used,
Mm-hmm.
but there was some physics equations in there as well, right? When you need to, right?
Got
So
it.
definitely some pre-processing, right? So you might have Fourier analysis as a pre-processing, to transform a waveform into Fourier coefficients and things like that as a simple pre-processor before you feed it into the machine learning. Um, so yeah, just spoiler alert: pre-processing is absolutely essential in all AI work, right? You can't just take raw data and dump it in the AI algorithm. And
Interesting.
that pre-processing requires domain knowledge, right? What am I actually interested in?
Interesting.
Um,
Interesting.
so is Fourier the right approach, or is it wavelets instead, or something else? So that has to be decided. And then certain analyses are purely physics based, right? If you're looking at thermodynamics, like you mentioned yourself, right? You might then want to do certain checks, like is energy conserved?
Yeah.
Is matter conserved? If you see that, for example, matter conservation does not hold in your system, conclusion is you have a leakage,
Yeah.
right? And that could be deadly to people, right? If the wrong thing leaks,
Correct.
right? Or if you don't have energy conservation in your system, right? Then you have a wastage somewhere. Some energy is being vented to the atmosphere that you don't want,
Yeah.
right? So there are certain physics checks that you do on the system to monitor it as well.
Got it. Got it. Very interesting. And uh, you the way you mentioned that you started this company, you were you know I mean, it felt like the industry became a outcome of what you were trying to do. But during these 15 years, right, neural networks came back strongly and they started seeing applications across different domains, different industries. But you stay focused on oil and gas industry, or did you try out different industries? And then what was the thought at that time?
Yeah, so me and my business, we were mostly focused on that oil and gas petrochemical sector. The reason for that is less related to the technology aspects that we've been discussing and simply more related to the realities of being an entrepreneur and doing business.
Hmm.
Um, so their focus is a good thing, right? As a business person, because the primary asset that you have is not your product, but it's relationships of trust with other people,
Got it.
right? And so once you've established that, and it's a lot of work to establish that,
Yes.
and
Yeah.
once you have it, then you got to keep up with these people, right? You have to touch base with them. You have to travel there. You have to have lunches and dinners with these people, and then they give you work to do. Then you do the work, and then you're in the loop.
Hmm. Hmm.
Um, and that's how businesses specialize in stuff, because of that. And at some point, you basically hit your capacity of what you can cope with. Um, and as you might imagine, the oil and gas industry is a global industry. And so there's also a lot of interest. You meet lots of people from very diverse backgrounds. You start traveling to some very unusual places, and you get involved into that world.
Correct. Correct. That's
So
true.
in terms of industry, I stayed true to that path.
Hmm.
But the technology did evolve over the years as new information came out.
Yeah.
So I stayed in touch with academia, and we then ended up deploying, all the new methods that came out to try to
Mhm.
do a better job. And as we know, in somewhere in the middle of the 2010s, the whole vision thing became very good,
Correct.
right? That was that famous case where in the ImageNet example, computer vision ultimately became more accurate than people did. And I,
Mm.
th- I think that happened in 2014, something like
Correct. Yeah.
that. So that was the big eye-opening moment where this term deep learning really
Mhm.
came out to the forefront, where people thought like, oh, this AI thing is back.
Yeah.
Um, it works now,
Correct.
right? It took these morons 20 years to figure it out, but now,
Now,
now they have something again.
yeah,
Um, so yeah, that of course then became apparent. Side by side, imaging hardware became cheaper,
yeah.
right? uh, Prior to 2010, imaging hardware was kind of expensive, right? Then the price started to come down. Mobile phones started to have cameras on them.
Hmm. Hmm.
Right? We take it for granted now, but this is only a few years ago that we didn't have that stuff, right?
Yeah,
Smartphones are relatively new.
relatively new.
Um, so in the industrial sector, um, cameras didn't exist 20 years ago. Now they do, right? So now we have visual information, and we can use that as part of those control systems and part of the AI systems to
Yeah.
monitor stuff based on cameras, right?
Hmm.
So now, for example, we have systems in place that will check whether everybody out there is wearing a hard hat and a safety vest.
Yeah. Mm.
As an AI vision algorithm, that contributes a lot to people's safety. But 20 years ago, you couldn't have done that.
Correct. Correct. That is true. That is true. And as an entrepreneur, as you mentioned, right, there are several hats you need to wear, right? You mentioned keeping the business relationships and making sure that the clients are happy, to also keep a track of what's happening in on the technologic front, and how are these algorithms, plus I'm sure a few other things, right? So how was that journey like, and how did that kind of transform you as a leader? And then, let's say if someone is trying starting a new business today, what would be your advice to that person?
Good question. Yeah, so I started out really as a geek with technology in my pocket,
Hmm.
um, expecting that the industry would basically say, "Wow, great, you have this on offer. Let's do it." Right? I was totally naive at that time,
Hmm.
and really, what I've come to learn is that what you have on offer, the technology that you have, the service that you provide, is not important.
Hmm.
Um, Of course, you need to be somewhat good at it. That's table stakes, though.
Hmm.
What you really need to do, the whole focus of being an entrepreneur, of having a business, is having a relationship with your customer.
Hmm.
And that's not a business relationship, not a paper relationship, not a contract. It's not a relationship between your business and their business. It's a relationship between two human beings.
Yeah.
Uh, so that means you kind of have to stop being a geek, which is hard for those of us who are geeks. Okay, very difficult for me. I'm an introverted nerd, right?
Yeah.
But now I have to be an outgoing traveling salesman, and I mean that literally. I traveled a
Yeah.
great deal
Mhm.
to my customers, right? The customer doesn't come to you; you have to go to
Yeah,
them.
correct.
And if you're dealing with a global industry, that means traveling a lot,
Mhm.
um, being somewhat more outgoing and extroverted, and developing these relationships. Um, Asking a lot of questions, figuring out what they need, right? What you have on offer is unimportant, and
Correct.
they don't care,
Yeah.
right? The important thing is for you to figure out what they care about.
Mhm.
What is their problem, right?
Right.
So even though like artificial intelligence might be helpful to them, if it's not their number one or number two priority, they're not going to do it.
Yeah.
Right? So you have to find out what their pain points are, and if you can't help with them, you need to be honest and say, "Well, I feel your pain, but I can't help you with that."
Mhm. Mhm.
Yeah. Um, and then over time, they build some trust in you that you're not just another Silicon Valley guy going, "It's awesome." Right? Most of the time, it's not awesome,
Mhm.
and
Yeah.
that's okay.
So true. So true. Mhm. Interesting. And during this period, you continued to stay out of Germany, or you had moved to the USA, or you were just traveling across, so it didn't matter as much.
It didn't really matter where I was based. Yeah. So I was living in Germany for much of this time. I spent a few years in Austria. And about 7 years ago, I moved to the United States here, but for unrelated reasons. Um, and the business was continuing.
Okay, cool.
Um, so to close that loop until the present,
Hmm.
so about 4 years ago, the business was acquired,
Okay.
and conveniently I got a job offer by Samsung to run the AI division at Samsung. So I did that until 6 months ago.
Okay.
That was a very rewarding experience where I was an intrapreneur,
Hmm.
developing the business within a very large global corporate environment.
Hmm.
Um, and as a non-Korean, doing that in a Korean corporation was a very interesting experience in its own right.
Yeah.
Um, and then 6 months ago, I joined the consulting industry. I joined a company called Sears,
Yeah.
where we do professional services in and around the cloud, again with AI. So I'm now a consultant.
Wow. And what did these changes, right? So from running your own venture to working in Samsung and then with a very different culture, did to you as a leader, and then what were some of the learnings? And then also, you were now, instead of looking at multiple aspects of business, you were focused on probably using artificial intelligence and then trying to kind of map it into Samsung's roadmap and products and specific questions, right? So you went from a very broad role to a relatively narrower role in that sense, but again in a different culture. What was your experience and learning as part of that?
Yeah, the role at Samsung was a little bit narrower than having my own company, but not all that much narrower, because
Mhm.
still the objective was to develop products and sell them. Right.
Okay.
So it was still the full spectrum,
Hmm.
from product development, finding customers, convincing them, performing the services engagements that are necessary on the outskirts of the product, and driving all of that. So there was a marketing, sales, product development, management, engineering aspect to all of that.
Yeah.
So it was a really as we say, an intrapreneur role. You have an entrepreneurship, but it's in the
Yeah.
corporate
Yeah.
environment. So now, instead of having like a board or an investor, you
Hmm.
have a corporate environment. Um, and of course, Samsung, with essentially 1 million employees worldwide, is a pretty big one.
Yeah.
Um, and so they have all of their processes and procedures that are set in stone, that you have to get used to, and you have to find your path in the company, um, and deal with the fact that major decisions are taken in Korea, and there are certain communication paths that you have to watch out for. So learning how a big corporation functions was hugely interesting and very rewarding
Hmm.
for me. So I can only advertise that again to the listenership, right? If you get the chance to join a big corporation somewhere in the middle management tier, that is a very rewarding learning experience, to try to figure out how those processes work. And then if you end up at a somewhat smaller company, you can take a lot of those learnings with you
Yeah.
and implement that. And that's partly what I'm doing at Sears now, is to implement some of these processes of the bigger companies to try to make this more streamlined.
Got it. Got it. Interesting. And any specific, projects or problems which you remember from the Samsung days, which and so uh, the challenge which it posed, and then the efforts and the solution to solve those problems, which you can share.
Yeah, absolutely. I mean, there are many AI things that you might know having. If you have a Samsung phone, it recognizes your fingerprint or your face to open up. There's Bixby, which is the equivalent of Apple Siri, where you speak to the phone and it does stuff. So those are some of the user-facing AIs on the consumer products. You can imagine that on the other side, because Samsung makes all of its own devices, there's a lot of stuff in the manufacturing side,
Yeah.
which connects very easily to what we've been talking about in the oil and gas sector, right? It's the same sort of stuff. Machines fail.
Yeah.
There has to be forecasted. Products in the manufacturing pipeline get damaged, and so you're producing scrap.
Mhm.
Right? Detecting that is delicate, particularly in a semiconductor field where the damages might be extremely small, micrometer type scratches that obfuscate the product. So some of that stuff.
Mhm.
The really interesting stuff that I really loved doing was on the healthcare side.
Mhm.
So among other things, Samsung does produce ultrasound and CT devices.
Yeah.
Um, and they take an image, CT and a picture, and ultrasound a video,
Mhm.
and then you want to know, what's up, right? Do I have cancer? Is the baby okay?
Yeah.
Um, and So we try to answer that using computer vision,
Oh.
where we would take that image, put it through the AI algorithm, and you basically get an immediate feedback.
Mhm.
And the accuracy of those algorithms turned out to be 98, 99%.
Wow.
Whereas the accuracy of a human doctor, right? As much as I love the trusted relationship to a human doctor, the accuracy of the average human doctor is more like 70%,
Mhm.
right?
Well, that's
So
the difference.
while it's a bit cold-hearted to get the feedback from the AI, it is more accurate on
Yeah.
average.
Right. Mhm.
Um, the market of getting second opinions on medical images is already a multi-billion-dollar industry.
Correct.
If you can get that second opinion from an AI that is virtually for free, that's a big gain,
Yeah.
right? And you get that feedback right away. You don't have to wait for it. So we did some more work on pathology. Pathology is where you take a biopsy from your tissue, you put it under a microscope, and you ask, "Do I have cancer?" Currently, at least in the United States, you have about a 6-week wait before you get the answer to that.
Mhm.
Right. So you can imagine you go in and you get a biopsy taken and you're sitting around for 6 weeks, right? Before you get, yes, you've got cancer, right? Those are bad 6 weeks, right? uh, if if you can get an answer that same day,
Wow.
that's big. That's a big benefit, right?
It
And
is.
that's what AI provides. So that's the sort of stuff we worked on at Samsung.
And from a UI perspective, right? Because these are very interesting problems, and then was this interface added to the machine? So it's still the doctor getting assistance, or uh, there was a way for the actual patients to directly get a second opinion from the machines? And so I mean, how did the user interface layer on this work?
Yeah, it's doctor facing.
Doctor.
Um,
Mhm.
so the doctor gets extra feedback,
Mm.
and effectively an assistant.
Okay.
Um, but for reasons of liability, the doctor has to clear it
Got
before the patient sees it.
got it. Interesting. Interesting. In both the use cases, the same.
Yeah,
Got it.
yeah,
Interesting.
yeah,
Mhm. Interesting.
yeah.
And
So
then,
that's the other thing with all of these things.
mm,
In any kind of AI application or entrepreneurship, right? You have all of these boundaries of legal regulations, and ultimately the contracting and liability laws that you're exposed to, right? So you have to watch the entire ecosystem. There are some things that you might want to do,
mhm.
but that might open you up to a kind of liability that would destroy you on day one.
Correct. Correct. Exactly. Exactly. That is so true. And then after just slightly more than 3.5 years, I guess you moved to Sears, and what was what is your role at Sears? What are you trying to do? And then again, is it new set of technologies, or building on what you were doing at Samsung?
Yeah, so at Sears, I've been here 6 months. I lead two business units: the business unit for AI and the business unit for data analytics.
Mm-hmm.
That's again a global function where we do projects,
Mm-hmm.
right? So we try to acquire and do projects. So a project, of course, has a well-defined beginning and end. So we're not developing a product. Uh, so that's a kind of new thing
Mm-hmm.
for me anyway. I used to, for the most part, as we said, develop products, which then you do that over years and years.
Mm-hmm.
Here it's kind of come in, get the job done, go home,
Yeah.
kind of a thing.
Mm-hmm.
So that's very exciting. It's a big team
Mm-hmm.
of people, so there's a lot of management aspects. We do 800 projects a year,
Wow.
um, so there is quite a big amount of deal flow, as we say.
Mm-hmm. Mm-hmm.
You know, where you have a constant stream of trying to figure out what does the customer really need. Right? So one of the principal learnings there, since we're on the topic, is that one of the principles that I have is the customer never needs what they want.
True.
So when you first get on the call with the customer and they say, I want this and that and the other, if you then write that down and do it, your project will fail.
Yeah.
Um, because what the customer actually needs is something else.
Right.
And that's why you have to critically ask and ask and ask to dive into what is the root cause, because what they're telling you is the symptom.
Yeah.
You need to discover what's the root cause, right? And so that's the first work of the consultant, is to figure out what the actual problem is and then to attack that. And the way we attack it is primarily through cloud technologies.
Mm-hmm.
So that, of course, is the new development of the last few years, that we have cloud available.
Mm-hmm.
And as much as, again, the geeks and nerds out there like me think that cloud is simply a standard, it is not a standard. Many businesses out there do not use the cloud at all.
Yeah.
Many don't want to use the cloud, right? So this is still a novel technology, but that's most of what we do. Is we deploy cloud technologies in the hyperscalers typically. Um, we then configure those products to the needs of the customer, train them, deploy all of that at a production scale,
Mm-hmm. Interesting.
um, and ultimately quantify the whatever the benefit is.
Got it. Got it. And you've been in middle of AI and cloud for the last so many years. And if I look back at the last, let's say, year since the time ChatGPT came out, right? There has been a mad frenzy of doing things with generative AI to figuring out what it means, and then again, sort of what you referred to, the neural network euphoria, that it can solve everything. So a how are you seeing this? And was there a surprise moment for you when you came across this technology? And then how do you see this whole thing developing?
Yeah, that's of course the exciting part of the last year. So just to start off with, large language models have been around for several years.
Yeah.
It's just that nobody outside the industry noticed it, because the way of interacting with them was through an API.
Yeah.
That's the innovation that OpenAI did with ChatGPT. It wasn't the creation of the large language model that we know as ChatGPT.
Yeah.
The real innovation was the interface.
Yeah.
The fact that you could talk to it like an SMS type messaging service, right? That was the new thing. And suddenly everybody saw it and was like, wow, what?
True.
It really can do that. And so that's how it became famous, and it collected lots and lots of users overnight. But in my view, calling those people users is really fake,
Mm-hmm.
because what they were people playing around with the technology. They were just like, "Oh, this is cool. Let me ask a few questions, and how are you? Ah, great. Yeah, where are you from? This kind of a thing, right?" They were playing with it. They weren't using it.
Mm-hmm.
And for the most part, that is still where we are today.
Okay. Mm-hmm.
So also from the point of view of now a consulting company, we are having a lot of conversations with mid level managers, top level managers about AI, generative large language models. What can it do? What can it not do? We're seeing some projects that are called proof of concept,
Mm-hmm.
um, where again you're basically trying things out. Um, but projects along the lines of let's actually do it
Mm-hmm.
at production, at scale, with lots of people, those projects are still very rare.
Okay. Mm-hmm.
Right? So if we're thinking, who is profitably using large language models? Well, the answer is not very many.
Yeah, it's OpenAI making a lot of money at the back of it. And
Um, yeah, so I'm a bit skeptical about that, honestly, because it is very, very expensive to,
okay.
first of all, make large language models, and
Mhm.
secondly, run them.
Yeah.
Right? So these companies that are involved here, like OpenAI, but many others as well,
Mhm.
it's expensive to run those, and I don't think that anyone is profitable.
Yeah. In fact, Google released Gemini, this week itself, and I think as part of their release itself, they've said that they don't know how to monetize this technology, and then they are clearly stating that the model has been trained across different data centers across a humongous amount of TPU cores, but it's still not clear how it would be monetized. So yeah, that definitely is the case.
Yeah,
Uh, but in the use cases, POCs which you are seeing, or those conversations, what is the feeling like, and are there any specific use cases which you see coming again and again, and then are there any use cases where this could actually solve some specific problems really well?
absolutely. So the most popular use case we're seeing is called enterprise search.
Mm-hmm.
Um, so we're all familiar with what an internet search is, right? You go to Google and you type in three words, and then it gives you a list of web pages. You then have to click and see, does that web page answer whatever question I had?
Mm-hmm.
So the work is on you. Um, with enterprise search, so first of all, the search is over the proprietary data inside your company, not on the internet, but on the intranet,
Yeah.
right? So the context is different.
Mm-hmm.
But on top of that, you're not going to type in two words, you're going to type in two sentences, asking a holistic question.
Mm-hmm.
And then the Gen AI will go in and look at all of the documents and find bits and bobs, and then assemble the bits and bobs into an actual textual answer,
Yeah.
right? It will not give you a hit list of things that you have to look through. No, it will
Mhm.
give you the answer
Correct.
backed up by sources. So that's the novel thing that we can do now. And when I say documents, I don't just mean text documents, it like essays, but rather it can go through audio, video, slides, images, through every type of file,
Mm-hmm.
and grasp the information that's in there and present that to you, right?
Yeah.
So, if I were to ask, simple questions like, okay, what's the relationship between our company and this other company? The answer might be, okay, you've got an NDA with them. Here it is. You have two outstanding invoices. Here they are. Your point of contact is, Miss X. Here are her contact details, and so on and so forth, right? And suddenly I have picture of what's going on. I
Mm-hmm.
have links to the source documents if I need them, but for the most part, the answer is right there. Right?
Mm-hmm.
That's enterprise search, and that can save a lot of time and resources of various people.
Yeah.
Another one is summarization.
Mm-hmm.
So I can ask for a summary of something, either a text document or a video or an audio file, or of many audio files. So, for instance, when you call somebody's hotline, they usually say, "Oh, for training purposes, this call may be recorded."
Yeah.
But let's face it, if you're going to record, I don't know, 5,000 phone calls every day, who's going to listen to them?
AI.
No one,
Yeah, that is true.
except generative AI,
Correct.
right? So what I can now do is I can say, "Dear generative AI, look over the last 1 million recorded phone calls and tell me what happened.
Yeah.
What's the common message? What is the most typical problem? What's the most common question I'm being asked? Are most people happy with my customer support, or are most people angry at my customer support? You know, Gen AI will be able to access the totality of those phone calls and give you a meaningful answer.
Yeah. Yeah.
That's something you could never do before,
True. True.
right?
And in the first use case which you mentioned, the enterprise search, uh, you could either say to the model that only use the data which I am providing, or don't look at any of the outside data, because that could change the connotations. Or
Right.
if you but in that case, some of the open questions may not get you may not get answers to those questions. Or you say, I'll keep the model open, but then in that case, it might still hallucinate and not give you. So there is that trade off between the accuracy, and then how much can you kind of reliably use in an enterprise context. So any specific thing you've seen working, or any specific direction where you see this going out of the different options?
Yeah, yeah. So what you're referring to in AI speak is basically called prompt engineering,
Mhm.
where you take the question that you have, and then the system or other experts supply lots of context to that. So that the question you ask is called the prompt, right?
Yeah,
And prompt engineering basically means that I'm going to add a lot more information to your question to give it that context. And the context could be, don't look at any internet sources, only look at my internal sources.
yeah,
Or it could be data governance type rules of, this user is not permitted to see documents of this sort,
correct. Hmm.
right? So all that is the context that has to be added. And yeah, we call that prompt engineering, and that's certainly necessary
Hmm.
to keep the hallucinations low.
Sure. Great, great. uh, and uh, in terms of, if I have to ask you, how do you see AI in developing in, let's say, next 3 to 4 years, or whatever horizon you want to answer that on? What are some of the key things we would probably see in this horizon, and what would be most exciting developments for you in this period?
I think in terms of the technology development, we've kind of seen it.
Hmm.
So I don't expect that in the next couple of years there will be another really dramatic technological evolution. I think right now everybody's busy trying to make money from what they've already developed.
Hmm.
Um, so that's always a cycle, right? You develop something new and then you get greedy,
Yeah.
and during that I'm greedy period, you don't really develop new stuff.
Mm-hmm.
Um, so I see that going forward. I am hopeful that in the next couple of years, the customer companies will actually deploy some of that new stuff.
Okay.
As I said, in this year, in the year 23, people have been mostly talking and learning and not very much deploying. I'm hoping that in the years 2024, 25, some of those actual deployments will occur.
Mm-hmm. Mm-hmm.
Um, Past that, in the next sort of 3 to 5 years, what I foresee, or rather hope for, is that the healthcare sector will wake up to AI
Mm-hmm.
and will use some of that. It it doesn't necessarily have to be in the actual, you know, treatment of disease type things,
Mm-hmm.
but there is lots of paperwork, processes, documentations, billing, invoicing, coding,
Yeah.
on the sidelines of the actual medicinal part of healthcare that could be automated by AI. Bring a lot of automation to the healthcare supplier side,
Mm-hmm.
but bring a lot of positive health outcomes for us patients.
Yeah. Yeah.
Right? Nowadays, the doctor is really a data entry clerk, right? You visit the doctor's like looking into the monitor, typing whatever you say, right? How
Mm-hmm.
about freeing up the doctor from being a clerk to being an actual, human to human interactive individual, right? AI
Mm.
can do
Yeah.
that, and many other things. So that's really where I see the
Mm-hmm.
benefit to the general public going is through the healthcare route in the next few years.
Sure. And one last question. So, any particular advice you would give to people? So, to kind of people, one who are, let's say, in their mid management stage, but are already in data science and in middle of the section, and then second group which is still at a mid management level, but isn't really in data science as of now. So what would be your advice to these two segment of people?
Right. So first of all, I would say if you're looking to move up in the layers of management, um, your most important thing is that you typically have to demonstrate by doing it that you're capable of performing the roles and responsibilities of the next level up,
Yeah.
right? So if you're doing your job and then asking for a promotion, it's not going to happen. You have to actually do the next level job
To
and then
claim.
say, hey, look, I've already done all this. Why don't you just give me the next title, right? That's the way to do that. And the higher up you go, the less technical, of course, that job becomes, right? And the more important things like business, right?
Yeah.
Have you gotten the revenue? Have you reduced the cost, et cetera, becomes, and the most important part is communication.
Correct. Correct.
Um, and when we learn a foreign language, we typically say that there are four pieces of communication, right?
Mm-hmm.
Listening, speaking, reading, and writing.
Mm-hmm.
I say there are two more. There are six in total,
Okay.
and the two that are missing is creating slide decks and public speaking.
Yeah.
Okay,
Completely agree with that.
if you can write an essay, it doesn't mean you can write slide decks. That's a separate skill,
Yeah.
right? If you can talk one on one, it doesn't mean that you are able to talk 1 to 1,000. That's a different skill,
Yeah.
right? And the higher up you go, those two communications are your primary communications,
True. Mm-hmm.
right? So invest in acquiring those skills. Um, and those two skills don't benefit from certification, right? If you take a course and you get somebody to just, oh yeah, public speaking certificate, dunk, so what, right?
So that is true.
You have to demonstrate that skill by doing it, right?
Yeah. Mhm.
Right. So get yourself invited to give a keynote presentation or something like that. Make sure it's video recorded, um, and then have an asset that proves that you've done it.
Mhm.
Of course,
Mhm.
only in the case that you did it well. Yeah.
Great,
um,
great. Mhm.
but those are some of the essentials that apply to both of those categories of people. Now,
Mm-hmm.
if you're already a data analysis expert, good on you. Um, then, of course, your communication should be based on that fact, right? But there again, you hit a certain point where you're trying to communicate data analysis facts, and if you then communicate further by drilling ever deeper and deeper and deeper into details, you'll lose your audience, right?
Oh, yeah.
So there too, you have to focus on the fact that communication is your primary activity and data science is merely the content of your communication.
Correct.
That is a good mindset to have, as opposed to the primary thing is the data analysis. And I just have to get these idiots to understand it by rubbing it in again and again and again. That's the wrong attitude,
Yeah.
right? But most people do that.
Yeah. That is
Right?
true. So,
Um, and for those people who do not come from a data analyst background, my
mhm.
advice would be get some data analysis background.
Mhm.
Uh, and there, I would say getting a certificate is meaningful.
Is meaningful. True.
Right. So if you go take a training, and this doesn't have to be like a master's degree, but if you take like a 1 week course or one of those Udemy skills enablement things, and you can show that yes, I've taken it. Yes, I've passed that final exam that tested me on what's the standard deviation and all that good stuff. Right.
Mhm.
That's meaningful. Um, and if you can then demonstrate that not only do you know it, but you can communicate with it, you know how to read an analysis report, and you understand what a probability distribution is and how to interpret that to an actual decision,
Yeah.
then you're good to go to the next level.
Correct. Correct. Great. Thanks a lot, Patrick, for sharing your journey, your insights, and your perspective with the audience. I think tremendous learning and really great hearing from you and your learnings and through the journey. Thanks a lot for sharing those.
Thank you for having me. It's a pleasure.
Thank you.